If you've just recently started learning data science, one of the things you'll notice is a lot of the packages have these pre-prepared data sets that are there for you, the IRIS data set or the Boston housing market data set or others, and they make it very easy to start applying data science. But when you start working with raw data on an application that you're interested in, you'll quickly notice that much of the data is bad or it needs to be conditioned in some way so that you can start using it in data science. So this is a tutorial on how to prepare data to get into the correct form so that you can start doing data science projects. Now I'm going to just go through a couple of these tutorials. Some of these are already available for you in these cells. You can just download these and run it, and then you can run the cell. This is just generating some sample data, and then what we're going to do is have a couple activities that where we work to clean up the data. So this is data that's produced that has some bad data in it, for example, not a number or outliers or other things that might be wrong with it, and we want to clean up some of the data so that we can start applying data science. So the very first thing that you might want to do when you import data is to visualize it, and that was the purpose of the last tutorial, number 4, on how to visualize data, and in particular for identifying things like outliers, values that are far away from the normal trend. They might be due to a faulty sensor or a data point that was just collected or misrecorded in some way. And then you go down, let's go ahead and remove some of these. Now you can do that with kind of a manual approach, like in NumPy you look for anything that is not a number, and then you can print out the not iz, okay, and so you look for the ones that are not iz, and so there is true and there is true. So those are the two rows that we want to save. We want to save row 1 and we want to save row 4, or with Python indices that's 0 and 3. And so let's just go ahead and take that not iz, those are the indices that we want to keep, and when we run it we're just going to be left with just the 2 good rows of data. So this is one way just to eliminate rows of data that might have bad elements in it. Now you can also use pandas to do that. It's the drop NA function, and this is very nice because it just drops those values for you. Now this is from the data frame that we generated above, and it dropped those values for us. We renamed it as data, so you have to do data.droppedNA, but the output of that is a new data frame with the cleansed data. So there's data head with the NA values removed. And so there's also some graphical methods to detect things like outliers, and if I run this I can run something like a boxplot, and I can see immediately here it identifies these 3 values as outliers. And so I might create some kind of condition just to eliminate those from the set. So there's other methods such as a Grubbs test or other statistical methods that can detect outliers. Grubbs test, it's only to detect a single outlier. So you can do other things like data where the data is less than 30, and it'll just keep that data instead. And so I've just eliminated anything above 30, and then you can see it didn't identify any additional outliers in the data. Alright, so let's go on to this first activity. This is just for time. We're going to just run this, and this one is to try to push enter, the key enter, in 1 second intervals. So if I run this, I'm going to start, and then you just need to not use a watch, but just see if you can estimate about how long it is for 1 second intervals. You don't need to put anything in the box, just hit enter. So I'm going to try to do it. You know, it's Mississippi or alligator or something like that might help you to count. Okay, so I'm going to do 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi, 7 Mississippi, 8 Mississippi, 9 Mississippi, 10 Mississippi. Okay, so there we have it. And now the next thing is to just add a box plot to identify any outliers. So I just collected some data from myself from hitting the enter key, trying to get as close as I could to 1 second. So let's see if any of those are outliers. And we're just going to add a box plot. Okay, so to do that, we're going to do plt.boxplot, and let's do tsec. Okay, that's going to be the time in seconds between the different keystrokes that I hit, the enter keys, and then I will show it. All right, so here it is. I was a little bit slow on my Mississippis there. You can see my my median value here with my quartiles, and this is my range. So it wasn't quite a second. I was about 1.1 seconds, but fortunately there are no outliers there. If I did have outliers, I could remove them or you know, something else. But here's the distribution in the times that I got. Actually, I was pretty good, 0.07 seconds away from each other on the time that I hit. All right, so the next thing that we want to talk about is scaling data. Scaling data is important because many of these algorithms work best if the data is between 0 and 1. And you can think of it like, well, I have data maybe barrels a day that my refinery processes. It might be 500,000 barrels a day, but you know, algorithms, a lot of these algorithms are going to work best if we scale the data first and just to 0 to 1, and then you can unscale it again if you want a prediction. So one of the ways of doing that is to import the sklearn preprocessing library, and we're going to import the standard scaler. Now, a standard scaler is interesting because it doesn't just do a min-max. It will look at normalized to 0 mean, standard deviation of 1. And so it's one of the common scaling methods to fit. Okay, so if you run fit, there's two different ones. You can do transform and fit, or you can combine them together into the fit transform. So it'll take your data and it'll take each of the columns and scale them according to the standard scaler. All right, so let's go ahead and just run this. And this will transform the data. So you can see that it transformed each one. I'm just printing 5 rows there. If you want to print 20 instead, just see a little bit of the distribution in the values. Okay, let's go on to the next one now. So this one, after it comes back, this DS value right here, it turned it from the very nice DataFrame into a NumPy array. And I might want to get it back into a DataFrame. I don't want to lose my column headers and things like that. So one of the ways to do that is just to say DS is going to be this NumPy DataFrame, and I want to use the columns from my prior data columns. Okay, so it just says use the same columns, but you know, you turn that back into a data frame, and there I have it back. All right, so let's go ahead and the next thing we want to do is when we're training these is to divide the data. We want to save some of our data apart when we're using machine learning so that we can validate the model. And this is important because if you train the model and you have, let's say, more parameters than you need, it doesn't fit, it doesn't predict very well, then it isn't necessarily a very useful model. So we want to save some of it aside. Typical rule, if you have plenty of data, is maybe 80% for training and 20% for testing. Well, that depends on your application. So this is one way to divide it. Just figure out the length and then you just say 0 to the dividing line. Just make sure that's an integer. Okay, we converted it into an integer right here. And then also the train and test. Okay, and so let's just look at the length of those. The length of my training set is 76 and the test set is 19. All right, so another way to do this, it's very convenient, is to import the train test split function, and then we can put our data frame here and say what our test size is. One of the nice things about this is you can also shuffle the data. So let's do that, and you get the same type of distribution. All right, so let's go down to the TC Lab activity now. Now this is, we're going to generate some data with the TC Lab. It's going to be with some randomly inserted bad data. We're going to collect for about 3 minutes, and we'll read, or if you don't have a TC Lab, you can read from this online link, and this will have some bad values in it. You can see some of those like right here, and there's going to be some outliers in it as well. So if you don't have a TC Lab, go ahead and use that. All right, I'm going to go ahead and just start this collecting. And again, we don't necessarily know where those are going to be inserted, because we just use a random integer every 30 cycles, and it's going to then put bad values in there. Okay, so anyway, it's go ahead and it's going to start generating these. We'll only print every 10 cycles, so you don't even get to see all of the bad values. Okay, and then after this is done, we're going to cleanse, scale, and divide the data. So we're going to go through some of the things that we just talked about, but let's work on that as this is going. Okay, every 10 seconds it's going to shift down on me, but I think we can manage that. Okay, so data 5, we're going to read the CSV, and this can either be the URL like we had above, or we can read it from this file. Now in this case, we're going to be generating it from this file, so I'll go ahead and just copy that back down here, just read it one more time. All right, and then let's look at data5.head. We can print that, or just leave it like this, and then insert a cell below. Okay, so that's just looking at the data. All right, now we want to maybe eliminate some of these bad values and also drop the nada numbers. So what I'm going to do here is there's going to be some outliers that are going to be inserted into the data, and let's along with the data head here, let's go ahead and just do data plot. Okay, and we'll just look at what those outliers, where they are, and how we could maybe eliminate some of those. Okay, so I'm just taking my data frame and using the dot plot function to be able to generate the plot, and then I can look at the data head as well, just the first few rows of that. All right, let's apply some of our the methods that we learned about, like data 5. Okay, it's going to be data 5, and then I just want to look just at T1 and T2, so I don't want to look at the other values as well, and then I'll drop the nada numbers in there. Okay, so anything that's there in T1 or T2 that's not a number, it's going to drop that row. Okay, the other thing is I can look for spikes in data, rapid changes. The temperature shouldn't change by, let's say 3 degrees every second. And so let's go ahead and eliminate anything that's over that 3 degrees. Okay, so I'm going to do data 5 equals data 5. And then data, and I'm going to do the difference, okay, the difference and the absolute value of the difference. And if it's less than 3, then I'm going to hold on to that data. But if it's greater than 3, I'm going to throw away that data. Okay, and we can adjust this tolerance later. All right, so I've cleansed some of the data, removed the outliers and the nada numbers. Okay, and it looks like this is done. So let's go and just start this. Okay, so here we have our temperatures. Ooh, this is X and Y. Okay, so it successfully wrote this. Okay. Oh, you know what? tclab05.csv. It doesn't quite look like the right data here. Okay, so let's figure this out first, because I think we got 05 tclab.csv, but oh, you know what? I think we forgot to, did we close it? Okay, I'm just going to try to troubleshoot this really quick before we go any further. Oh, data 5, that's what it was. I was looking at data. All right, so there's the right data. Okay, and you can see here we have some not a number values right here interspersed, and then you also see some spikes, and we just want to clean those up. All right, and so let's go ahead and just clean these up, and I'll do data 5 plot. Okay, and I have an error, no numeric data to plot. Okay, so what happened here? Let me go ahead and just run this. Okay, let's look at data 5. I think I did something maybe up here. I need to run data 5 again. Okay, and run this one again. I have data 5. Okay, let's see, T1 and T2. I'm looking for data diff. Absolutely. I think I need to do something here because some of those other values change by a lot. Let me just go ahead and just narrow down data 5 just to those two initially, and then we can do the differencing on that. Okay, so then I don't need this here. And okay, I'm going to rerun this one more time, get my new data 5. This is the problem with using the same values over and over again. Okay, no numeric data to plot. I'm going to pause this really quick and figure it out. Okay, I think I found it. I just forgot to put data 5 right here. I shouldn't use data and data 5 to do that because it dropped all of those values. Let me run this one more time up here, and then I'll run this one. Okay, so here is the cleaned up data. We removed the spikes and we removed the not a numbers there as well. Okay, just left gaps in there. Some of these, there's just a gap, so there's a second or two that are missing along here. You could see a little bit of a glitch here and there, but I think those are just, you know, the sensor being just a little bit sensitive. Okay, but I think that looks about right. Okay, let's go ahead and insert a cell below. Let's do the standard scalar for ours. And I'm going to do standard scalar. All right, and DS5. And we'll do fit transform. And I'll use data 5 instead of data. All right, and then let's just print the first 5 rows of that. And another error, standard scalar is not defined. Okay, so I think in this case I need to go back up and import that again. So let me go get, I'll go get that standard scalar import. Okay, and that's from the scikit learn. Okay, and oh, I don't think we have it here. I need to go back and get it from the pre-processing. Okay, so okay, I think I just misspelled that. Let me do standard scalar. All right, there it is. I have standard scalar. If you did want to import that again, it's just sklearn pre-processing import standard scalar. Okay. All right, let's go on to the next one. Insert cell below. And the final thing that we want to do is to split it. and I'll do train and test, and then I'll use my train test split, and I'll just use my DS5, and test size is going to be 0.2. That'll be 20%, and shuffle equals true. All right, and then I can print, for example, the length of my training set and also the length of my test. So you can see that it split it 80-20. Okay, so in terms of preparing data, there's some things you can do in data science to prepare your data. One of those is just to visualize the data, look at your data, see where there might be some outliers, and then develop rules like eliminating not in numbers or dropping, okay, drop NA for pandas. You can also do things like box plots and look for outliers that way. And then develop conditions to help you cleanse the data automatically so you don't have to go through it and pick out bad data as you go. And the important reason why you do this is because outliers are going to have a very negative effect on the predictive capability of your machine learned models. And so you want to clean those up, because if you're using like sum of squared errors or mean squared error, those squared errors, if you have an outlier, they're going to greatly influence the result. And so it's really important to eliminate things like outliers or other bad data so that you get a good and consistent machine learned model.